6 inches. Okay, so let's look at a real problem. The distribution of playing careers of Major League Baseball players can be approximated by a normal distribution. So when you see those words, approximated by a normal distribution, you should immediately draw a bell curve, because the bell curve is going to be used to model this problem. The mean is 8 years and the standard deviation is 4 years. Find the probability that a player selected at random will have a career that will last less than 6 years, longer than 14 years, between 4 and 10 years. Okay, so ask yourself, does this problem give us area and ask for scores, raw scores or z-scores? If so, then we'll use IMV norm. Or does this problem give us raw scores or z-scores and ask us for area? Because if that's the case, we're going to be using normal CDF. So the question is asking us for probability. What's the probability? And in previous lectures, we linked probability to area. So since the question is asking us for area and giving us scores, because let's look at parts A, B, and C. Less than 6 years, 6 is a raw score. Longer than 14 years is a raw score. Between 4 and 10 years, these are raw scores. So the question is providing us with scores and asking us for probability, which basically is area. So we are going to use normal CDF. Okay, the problem is asking us for probability, which is an application of area under the normal curve, and the problem provides us with scores when we say less than 6, longer than 14, etc. Those are scores. So we will be using normal CDF to answer the probability question. Okay, let's look at a picture. For part A, we're trying to find the probability, and you should recognize now that finding the probability for a normal distribution means finding area. That a player selected at random will have a career that will last less than 6 years. So we have a normal distribution, which means we're going to label our bell curve. On the horizontal axis, right in the center, we're going to put our mean, which was provided in the problem, mu equals 8. And right below it, we'll label our standard deviation as 4. The raw score that's being asked of us, or rather, yes, the raw score that's being given to us, 6 years. 6 is on the left-hand side of 8, so we're going to make, basically, we can label 6 right here below this vertical line. We're being asked to find the probability, which is the area, that a player will have a career that will last less than 6 years. So if 6 is right here, less than 6 is everything to its left. So the area shaded in should be all the area to the left of x equals 6. Okay, what we're being asked now is, when finding the probability, is to basically find that proportion of area less than 6. So on our calculator, the proportion of area less than 6 is going to be, use a lower value of negative infinity or negative 100,000, an upper value of 6, a mean of 8, a standard deviation of 4. Okay. So what we're finding here is all of this area on the left-hand side of 6. Now, by looking at the picture, since 6 is on the left side of 8, we expect that this number, that this proportion of area that's going to come out of our calculator has got to be something that's less than 50%, because it's less than half of the bell curve. So I'm going to do this on the calculator with calculator. Second, DISTR, we're asked for probability, which is a function of area, so we use normal CDF. On the left-hand side, we're going to put negative 100,000. On the right hand side, we're going to put the raw score, 6. Our mean is 8. Our standard deviation, again, what was that? 4. And paste it. Okay, so the proportion of area is 0.3085 when rounded to 4 places, and that's what we're going to do by convention. We're going to round to 4 places. So, the probability that a player's career will last less than 6 years is 0.3085. We could express this easily as a percent. It would be 30.85%. Okay, so the probability that a player's career will last less than 6 years, 0.3085. So this proportion of area. Find the probability that a player selected at random will have a career that will last more than 14 years. Okay, our normal curve is going to be labeled again in the same fashion with our mean of 8 and a standard deviation of 4. 14 is our raw score that's being provided to us, and more than 14 represents the area on its right. Okay, so we start with an empty bell curve, and in the center we label mean equals 8, standard deviation equals 4. 14 is on the right side of 8. We're going to make a vertical line, and then we're going to shade the area all the way to basically positive infinity, from 14 to positive infinity, indicating that we're finding an area or a proportion of area for more than 14 years. More than meaning greater than, which is to the right. Okay, so we're going to go to our calculator. When we do this on our calculator, remember that if we need to find area that goes to positive infinity, the lower score is the score on the left, 14. The upper score is positive infinity, the score on the right. The mean is 8, the standard deviation is 4. And when you enter those values into your calculator, you could try it and round to 4 places, and you should get 0.0668, which means that the probability that a player's career will last more than 14 years is 0.0668, or 6.68%. Part C. Find the probability that a player selected at random will have a career that will last between 4 and 10 years. So when you have a question that asks for between, then there's no need to use positive or negative infinity, because you're finding the area between two finite values, in this case 4 and 10. So on your bell curve, you've got mean of 8, standard deviation of 4 again. 4, the first raw score, is on the left side of 8, and 10, the higher raw score, is on the right side of 8, and you're trying to find the probability that a player's career will last between those 2 points, which is basically the area under the bell curve between those 2 points. Okay, so on our calculator, we always enter the lower raw score first, then the upper raw score. So it's going to be 4 for the lower, 10 for the upper. The mean is 8. The standard deviation is 4. And entering that into the calculator, you're going to get an area of 0.5328. So the probability that a player's career will last between 4 and 10 years is 0.5328, 53.28%.